All right, in this video, we're going to talk about the process of how to get a 9-lead Delta motor running, even if the wires sticking out of it are not labeled at all. So generally, if you're to look at a 9-lead Delta motor and look at the wires coming out of the motor, they should be labeled T1 to T9, and then you can use some schematic either from the internet or from the manufacturer to get it up and running. And the reason why there's 9 leads to these motors that I'm talking about is they're dual voltage. So then you can hook them up in different connections for either a high voltage or a low voltage. So that's the starting point. So what we're looking at is a motor that doesn't have the identification on the leads, and we're going to still show you a process to get this thing to run. So the first step is to actually find a 9-lead Delta motor, and how we can do that is we ohm out the wires that are coming out of the motor, and we should find 3 groups of 3 leads. If it's something else, then it's move on to another video, because it's not going to be the motor that I'm talking about. Okay, in our classroom, if we, to practice this, what we have is motors with this plate on it, and it has 9 terminals labeled A to I. So I'm just going to write that down here just to help us out for practice in the classroom. So what's going on here is each terminal represents a wire to the motor, and there's 9 of them. Now, the next step is, once we establish that we found a motor that has 3 groups of 3 leads, is we got to ohm it out. So we got to do a continuity test with an ohm meter, and here's how we're going to do this. So we're going to draw out this diagram. So what we have is 1 group of 3 leads, 2 groups of 3 leads, and then the third groups of 3 leads. And we're going to label this diagram with the resistance values. So here's how this came to be. I get my ohm meter, I put it on wire A, or terminal A, and then I measure to terminal B, and I get OL, which means over limit of the ohm meter, which basically means it's open. Then I move to C, and there's no continuity there, and I go A to D, and I get a hit, and then my ohm meter reads 10 ohms. And so I write that down. A to D is 10 ohms. And I go A to E, nothing. A to F, nothing. A to G, I get a hit. And it also, it reads 20 ohms. So A to G, I have 20 ohms. And then I go back and check, and let's go, what does D to G give me? D to G gives me 10 ohms. Now, internally inside the motor, the way it's laid out is basically it's 1 winding, a terminal, and then another winding in a terminal. So if you look at my readings and you apply them to this chart, it should make sense. The 20 ohm reading, or the largest reading from A to G, should be the outside 2 terminals. And in this case, that's 20 ohms. Well, the halfway point will be half of that ohmic reading, which in this case is 10 ohms. So it makes sense. From A to D is 10 ohms. From A to G is 20 ohms. And then from D to G is also 10 ohms. So that's how that is all came to be, and that's why I labeled it like this. On a side note, I could have made this G and this A, and it would have worked just fine, because when we do this process, it's all relative to each other. So I decided to make the first terminal A, because it just makes sense alphabetically. But just realize that, yeah, you can do different things and still get the motor to run in the same fashion. Okay, moving on to the next. So then I moved my first lead of the ohm meter over to B. And then, I measured from B to C, and there was nothing. And then I measured from B to D, and nothing. And I kept on going until I got a hit. Well, B to H, I got 20 ohms. And then I moved B to I, and then I got 10 ohms. And then I decided to measure between H and I got 10 ohms. And using the same kind of process that we just did for the first group, it kind of makes sense that B to H would therefore be the outside terminals. That's how we'd label them. And that, in this case, 20 ohms. And then B to I would be the halfway point, or I would be the halfway point at 10 ohms. And then I to H would also be another 10 ohms. And then I did the same here. And again, so I just went on the C terminal, and I went around the wires or the terminals and went to D, and then E I got to hit at 10 ohms, and F I got to hit at 10 ohms, and then I moved this lead over to measure between E and F, and I got 20 ohms. And hopefully now it makes sense that between E and F, or they would be the outside terminals, and the C would be the center terminal. And one more time, again, I could have made this F and made this E, and it would still support what I'm drawing, and I could still make this motor run. Okay, now we are on to step 3. Step 3 is we're going to draw a 9-lead delta diagram. I'm going to move this up here, and we're going to label it. So let's just write out what I'm going to do here. So I'm going to label T1, T2, and T3 of a 9-lead delta diagram of a 9-lead delta motor diagram. And we're going to label it with the middle letters of our previous diagram. Okay, so here's the drawing. We'll see if I can get my color pen in action. The red's a little spotted, but it'll work. Okay, so for you people that are just looking at this and don't have the background knowledge, there is a standard of how to label these. So when I say label T1, T2, and T3, I'm referring this is T1, this is T2, and this is T3, especially with the way I have the phases with the red, black, and blue. I'm just going to fill in the red here. Yeah, it looks a little better. Okay, so instead of labeling this motor with our T terminals, I'm going to label them with the letters. So what's happening is, let's just look at the bottom of the screen here. I got this shape here. Well, I just put it like this because it's easier to understand as a delta 9-lead motor. But the way the ohm meter would read this is basically straight across like this. So if we're just putting this winding down here, it makes sense that this would be A, this would be D, and this would be G. Now the issue is I don't know if this is A or G, or if this side is A or G, but I do know that the D won't change. So I can confidently label this, that's my T1 terminal, as D in this case. Then I'm going to move to the second group. So this is group 1, this will be group 2. And I'm just going to label the center terminal as I. And then the third group, the center terminal, is C. So T3 will be C. So just bringing that back to what I just wrote here. So label T1, T2, and T3. So that's T1, T2, and T3 with the middle letters of each group that we identified earlier. So right now this is going to be my benchmark. And this is nothing, I'm not going to change these letters now from now on. If you were to redo this motor, you could change the groupings if you wanted. You could have made this C and this D and this I. Now the centers will never change, but I could, flip it around so, the top is now I or whatever. I just chose this, and I'm going to stick with this. Okay, we're going to move on to the next page, and that is going to be another video.